Good morning, everyone. I'm honored to introduce Professor Alan Hevner, the opening keynote lecturer of the second day of CHASE Conference 2016 for the study of innovation and learning technologies. Alan Hevner is an eminent scholar and professor in the Information Systems and Design and Decision Sciences Department in the Numa College of Business at the University of South Florida. He holds the Citigroup Eden River Chair of Distributed Technology. Dr. Hevner's areas of research include design science research, information systems development, software engineering, distributed data systems, healthcare systems, and service-oriented computing. Dr. Hevner received a PhD in computer science from Purdue University. Dr. Hevner is a fellow of the American Association for Advancement of Science and a fellow of the Association for Information Systems, as well as been awarded numerous other honors. His 2004 Management in Information Systems quarterly article, Design Science in Information Systems Research, has been cited over 7,000 times according to Google Scholar, and served as a major facilitator of advancing design science research, which is of interest to many of us over here. I'm glad to invite Professor Hevner to deliver the keynote lecture titled The Front End of Innovation, Implications for Design and Learning. And the floor is yours. Okay.
Thank you. Well, thank you, and welcome to everybody this morning. Thank you for the great hospitality. It's a pleasure to be here. My second time in Israel, but the weather is fabulous. Of course, I could say I brought it with me from Florida, but anyway, it's great to be here. And what I want to do this morning, I'll try not to stray too far from the mic here, is to explore some ideas with you. We're going to be talking about some research in progress that combines ideas of innovation, design, and learning. Okay, let's see if our clicker works here. It does. Let me first acknowledge that this is research in progress with a number of excellent colleagues that I've had the pleasure to work with, to include Dr. Shirley Greger from Australia National University, my colleagues at USF, to include Roseanne Collins, Grandin Gill, and Chris Davis. And this research has been partially funded from a grant from the Schuler Research Center from Germany. So quickly, and I'll move through this reasonably quickly, but what I want to explore with you is a number of, I think, very interesting ideas. You're going to see that there's a lot of fields that we draw from for these ideas of design, innovation, and learning. So start with a couple quotes. One from a leader of a government agency in Australia. Our department is continually being told to innovate, but no one tells us what that means or how to do it. Second, from a leader of educational technology, and who says it's time to dispel the myth that innovation only happens outside the classroom, and use that knowledge to create more collaboration between innovators, between entrepreneurs, and learning. So what is innovation? I think this is a good starting point. And you'll notice there's three quotes here. And I won't read all these quotes, but you can see that there's a difference in levels of abstraction from what people understand as innovation, starting from ideas, very conceptual, ideas of innovation. Knowledge, to say that innovation is knowledge and the growth of knowledge. And finally, you'll see in the third quote where people say innovation are systems and devices, actually instantiations of artifacts. So we have all levels of abstraction as we talk about innovation. So why do we want innovation? Well, again, I don't think I have to convince you too much of this, because there's been a large literature to say innovation drives economic growth and societal gains. The fact that we as humans are creative and can generate new ideas and advance human progress. It's necessary for business organizations. It includes products, services, modes of delivery. But we're in an era of we want innovation, but it's hard to define exactly what it means. And in particular, the idea of an innovation process. How do we perform innovation? How do we train people to be innovative? This is very questionable, and it's not getting the attention I think it deserves. We as researchers, we as people in the learning disciplines, we need to understand better how to train people to be innovative and to think differently. There are a lot of issues. If you explore the innovation literature and look at a lot of the practices that are out there, there's a plethora of terms. A lot of people categorize innovation in many different ways. You can see a couple up here: radical versus incremental, exploration versus exploitation, ambidextrous organizations. What does that really mean? Also, you'll see a lot of people presenting techniques of innovation, a wide range of practices: brainstorming, design thinking, crowdsourcing, road mapping, open innovation. What do all these terms mean? How can we have, if you will, a topology or a categorization of what it means to be innovative? We also find that when organizations and people are challenged to be innovative, there's resistance. They're saying, well, we're doing fine. We're making a lot of money, we're educating our students. There doesn't seem to be a tremendous need to do things differently. And we have to break that mindset. So we would argue that currently there is no sound theory-based classification for different types of innovation and different types of practices and how those practices apply to innovation. So the goal for our research, and again let me say this is research in progress, is to try to understand better what it means to be innovative, to develop a categorization and a topology for defining what innovation means. What we have discovered, and we come from, as you know, information systems, information technology, in our design science research, we have discovered that there are different types of innovation. One innovation doesn't cover everything. And so we would like to show that there are different patterns of practice for different types of innovation, and coming up with a good understanding of that. The figure you see here is from some work done by a group that have defined what they mean by the front end of innovation. And so we're going to focus on the front end. How do we get people started thinking about good innovation? I realize you probably can't read this figure, but what you see here quickly is an engine of innovation where we have opportunities, we try to understand ideas, to understand concepts, and then the engine generates new ideas and innovative concepts to put into new product development eras. So let's start with that point. We're looking at the front end of innovation. How do we get started on thinking about ways of being what we term here multi-disciplinary dexterous, or coming up with ways of understanding the different forms of innovation that are in the world. We start with looking at 4 grounding perspectives. We have to understand the knowledge that currently exists in innovation and how it plays together into an overall topology for innovation. So let's look at the literature for innovation, creativity, knowledge, and finally the field that I'm most proficient in, and that's design science. If you look at the innovation literature, it's vast. It's really honestly hard to go through all the innovation literature that's out there. Here I'm just pointing out a couple of important, if you will, guideposts along the way. Van de Ven's innovation journey that he talks about. The figure that I just showed you from Keown on new concept development and front end of innovation. Then some literature from the educational design field. Anderson and Shattuck do a survey of what design-based research means in the education field. And then IT. IT causes disruption. New technologies, the internet, mobile devices, Internet of Things. These technologies disrupt current ways of thinking and cause innovation, cause us to be innovative and creative in ways we do things. And then finally, the last 2 are practitioner-based models of innovation. Gartner has a hype cycle, and then McKinsey has what is known as a 3-horizon model of innovation. And I thought I'd show that to you just very quickly. Actually, you'll see 3 horizons there. And if you look at the axes, the x-axis is the maturity of the technology itself. So you start from existing tech that they're familiar with, existing tech that is new to the organization, and finally, new tech that is new to the world. The y-axis is our current markets that we work in, emerging markets that we'd like to be involved in, and markets that maybe don't even exist yet. So as we think through this, there are 3 horizons that organizations want to work through in terms of their new development. And you can see here in Horizon 1, it's just to optimize and be better at what we're currently doing. Horizon 2, we want to extend markets. We want to identify new markets that we want to be part of. And at the same time, we want to do some R&D to try to extend our current technology base to take advantage of some of the maybe new disruptive technology that is in the world. And finally, in Horizon 3, we want to enter new markets with new technology. And this is long-term strategy type of planning. So this is the McKinsey model of thinking about being innovative. And somebody would argue that, well, maybe Horizon 1 isn't real innovation, maybe not even Horizon 2. It would be Horizon 3 where the true innovation takes place. However, I would say that all of these horizons are innovative in a way. And this goes to my point that there are more than just 1 or 2 types of innovation. And we have to come up with a better way of understanding these categories of innovation. So there are a couple of initial attempts that have been in the literature that you can explore. In the field of marketing, Ansoff, back in '57 in the Harvard Business Review, published his Ansoff Matrix. March, in particular, in the early '90s, talked about innovation having 2 types. First, exploitation, which is more the Horizon 1 type of work there, and exploration, which means moving into new areas of demand. More recently, there have been a couple of very comprehensive surveys of innovation categories. But if you read those surveys, one of the conclusions is that we need better ways of understanding what it means to be innovative and what innovation categories are all about. So we would argue that currently there are really very few, if any, careful theory-based categorizations and analysis of what innovation really is. So, second, let's look at creativity, because we know innovation requires a base of creativity, human cognitive thinking. Now, there have been sort of two directions here. One is epitomized by Amabile, her work on computational models of creativity, where she defines what environments you need to provide a creative support structure for innovation. And she talks about being domain proficient, having creativity processes, task motivation to be motivated to be creative, and finally a social environment, teams of creative people. The second major push here is neuroscience, which we're seeing a lot of new work being done on where in the brain, where in the human anatomy we have sort of creative instincts, and how can we identify that and support it more effectively. And you'll see the quote at the bottom basically gets to the idea of left brain, right brain creativity, where, you know, what is creativity? Is it a mysterious result of spontaneous processing, or is it a planned, deliberate result of methodological problem solving? Okay, now this really gets to Kahneman work on fast thinking and slow thinking. You know, the fast thinking being intuitive, spurts of creativity, versus slow thinking, which is the analytical way of thinking through a problem to come up with a very effective solution. So with my colleagues at USF, we did some thinking about how this applies to the design field. And just briefly going through this model, you see it's again a 2x2. A lot of people enjoy 2x2s. So we're dealing with a problem space at the top, a solution space at the bottom, our external environment on the left, and our internal cognitive environment on the right here. So the process of coming up with new ideas, coming up with new innovative products would follow the pattern of moving from a fitness landscape to an internal mental model capability, then being creative, coming up with our design candidates, and then moving our instantiations, our use artifacts, into the field. Now, in the process of doing those steps, we can talk about what goes on in the brain. I mean, what specific capabilities do we as humans have to support this design process and this innovation process? Well, I've identified sort of 4 C's, if you will. We need to be able to deal with complexity. We need to organize the wicked problems and opportunities that we're dealing with in a way that we can come up with solutions for. Then we need creativity to come up with that insight, with those new ways of thinking. We have to have control, which is the analytical aspect of creativity, where we have to be able to refine and narrow down the possibilities to a feasible solution that we can actually implement. And then the 4th C, very important, and that is, how do we collaborate between minds? How do we come up with common, agreed-upon mental models, both of the problem and of the solution? So as we think about those 4 C's, we can say, what is the importance of cognitive thinking in innovation? Well, here are the 4 points. We have to be able to structure the problem. We have to manage complexity. We have to organize our thinking. in a way that helps us understand the solution. And we can go to actually Herbert Simon, Nobel Prize-winning economist, who basically said representation of the problem is 90% of the solution. And that's, I think, very true. Second is, how do we create novel, interesting ideas? That is where creativity comes in. Third, how do we manage refinement, or how do we control the analytical portions of our thinking to find the best, quote unquote, the best designs to instantiate and the best solutions for our innovation? And finally, how do we achieve that consensus? How do we collaborate with interdisciplinary teams, very disparate ways of thinking, because it has been proven that the more interdisciplinary thinking and diverse types of thinking, the better your solutions are going to be. And so how do we achieve those collaborations? Okay, let me move on to knowledge. And again, I'm hitting a lot of ideas here, and I'll try to pull them all together in just a little bit. Knowledge, innovation is about knowledge. And it's the growth of knowledge. It's how we grow knowledge in the human sphere of thinking, okay? Jay Mocher, in his work, he's an economist of knowledge. He basically talks about how do we grow knowledge and how does knowledge increase over time in things like the Industrial Revolution and in today's age. And then we have some thinking from Nonaka on the knowledge-creating company. So let me just briefly say that based upon this work, we can identify two dominant types of knowledge in the world: descriptive knowledge and prescriptive knowledge, where descriptive knowledge is our understanding of the world. We look at phenomenon, whether that phenomenon is natural, artificial, or human, and we try to observe, classify, measure, and then we try to make sense of those phenomenons, which allows us to come up with laws of nature, as well as principles, patterns, and theories of human behavior and of how the world works. However, the second type of knowledge, which is, in my mind, what we're talking about in terms of innovation, is prescriptive knowledge, where the human creative abilities build artifacts and theories. And in particular, we classify artifacts in four ways: constructs, models, methods, and instantiations, the actual systems themselves and the processes to use the systems. So I'll expand on that in just a second here. Okay, fourth perspective, the one that I'm most comfortable with: design science research. Again, drawing from Herbert Simon, who did some tremendous work. His book was called Sciences of the Artificial, where he talks about human ability to solve problems and the creation of innovative artifacts to solve real problems. Now, we know design has been around since the beginning of time, essentially. I mean, humans have been designing solutions to problems in engineering, architecture, art, education. And they have identified the role of creativity in design. So here's our reference to our 2004 paper, the one that Nitsa mentioned has over 7,000 citations. We pulled these ideas together to talk about the field of information systems. But I've been very pleased to see that a large number of those citations have been from many other disciplines, to include education and architecture and all the engineering disciplines, because they've identified the commonality to say design science is important. You know, we can design things, but what makes it a science? What makes it a true contribution to new knowledge? So here's just a quick diagram of the process of design science, where we have essentially three cycles. We have a relevance cycle, where we draw the problem and the relevance from a real-world environment. We have the rigor cycle, where we draw from existing knowledge base of theory, of expertise, and of existing artifacts, because we want to extend the knowledge that is in that knowledge base. And then we have the process of doing the design science project, where we build and evaluate. Now, the contribution, what makes it research, is the two contributions we make here. One is we make a contribution into the real world. We put that artifact to use. We use it in demonstrations and then in actual operation. And we then measure its ability to improve our performance, to improve the quality of the products that we produce. The second contribution is to the knowledge base, where we add new thinking, new artifacts, new ways of doing into that knowledge base. Most often it's prescriptive knowledge that we're adding, but frequently also it's descriptive knowledge, because we're putting that artifact into use and then we're analyzing how humans use that artifact in the real world. Now, I know you come from a large number of different disciplines, so I'm hoping you're thinking, how does this apply to my research? So, happy to answer those questions later. In the 2004 paper, and I'm not going to go over this in detail, we identified 7 design guidelines that we think any good design research should have. Okay, you know, we've been criticized of being too prescriptive here, but we're not trying to be. We're just saying these are the guidelines. This is what you should think about. And quickly, what is your artifact? Number one, to do design, you have to be designing something. What is the artifact you're designing? It doesn't necessarily have to be a system. It could be a model. It could be a method. It could be a concept, okay, a construct. How is it relevant? How are you evaluating it? And this is a real challenge for researchers. Hey, I can come up with a new artifact, but how am I going to evaluate its goodness, its effectiveness, its quality to solve the problem? What research contributions am I making here, both to the field and to the knowledge base? How have I appropriately made this research rigorous? Do I know the literature? Have I drawn appropriately from past work so that I'm not reinventing something? 6, the search process. This is subtle, but it's important. How did I refine the ideas or the concepts and characteristics of the artifact itself to come up with the best artifact? Most design problems have multiple dimensions of freedom, so you can make a lot of different choices here. It's a search space that you're looking across. And how have I found, if you will, the local maximum, or hopefully a global maximum, but to quote Herbert Simon, typically we're just trying to satisfy here. We're not trying to be optimal. We're trying to find a good, as close to best as we can, solution. But we need a solution that works, is feasible. And finally, communicating this into the journals, into the conferences, as well as into the real world. We have to understand who our stakeholders are for any design, because your design choices will advantage certain stakeholders and perhaps disadvantage other stakeholders. So we have to understand, if you will, the ethical component of doing design also here. And there's a whole field in literature on the ethics of design. Okay, we talked about the artifact. I keep using that word. Well, what do I mean by the artifact? And there's a wide range of abstraction here. And it's important that we understand this, that from the bottom to the top, we get more abstract. So as we do research, if we're researching a very interesting and new problem, just building a system is a research contribution. So a situated implementation of that artifact makes a contribution because it hasn't existed before. Now, as that field gets a little more mature and we have, say, competing artifacts, then we start to try to generalize our understanding of why those artifacts work the way they do. So at level 2, we call that nascent design theory or beginning design theory. Principles, architecture. We try to generalize now our thinking to more than just the situated environment that started our project. And finally, at level 3, we can talk about more mid-range theories, design theories that are well understood, and we understand why artifacts work the way they do in certain situations. And we can categorize those situations. So keep this idea of artifact abstractions in mind as we move forward here. Okay, now let's start pulling it all together. Remember, we've got innovation, we've got creativity, we've got knowledge, and we've got design. Let's pull it together in what we term a knowledge innovation matrix. Shirley Greger and I have worked with this and have presented it really across the globe. Here it is, and you'll see some similarities to the McKinsey, but I think this is a cleaner, more theory-based way of presenting the distinction between different types of innovation. So, x-axis. Here is the potential solutions we have and their maturity from low to high. So this is the solution space. On the y-axis, we have the application or the domain. Again, from low maturity to high maturity. So essentially what this axis is saying, do we understand the problem? Or is it a new problem? Is it something we really haven't thought about before? Is it a new opportunity to us? Or is it an opportunity that's been around a while? We just want to do a better job with it. What solutions do we have? You know, do we have a number of well-understood solutions and artifacts and systems for that problem? Or again, is it an area where we have very little knowledge at this point? Okay, so this 2x2 shows, we believe, 4 very different types of innovation. From invention, where we're inventing new solutions for new problems. Boy, this is high risk. This is high risk, high reward. It's an area that we have little guidance. Okay, so our innovation pattern in that quadrant is going to be, very open-ended. We want really creative people for that type of innovation quadrant. Let me move to exaptation. This is a term from biology, which basically says we'll take a human trait and adapt it to a new purpose. And the classic example are birds, actually, where feathers were initially purposed for warmth, and over years of evolution, they became purposed for flight. Okay? Here, it's a brand new problem to us. It's a new opportunity, but we have some interdisciplinary knowledge to say, hey, there are some potential solutions in other fields. Or we may have some new technology that has just been developed that maybe we can apply to this new problem where it hasn't been applied to this problem before. So we're extending known solutions to new and different problems. Some very interesting examples in that space. Advancement, we understand the problem pretty well. It's been around for a long time, but we need a better solution. Our solutions are relatively immature, and so we want to come up with improved solutions for that particular problem. Now, this is sort of traditional R&D. This says, hey, we know the problem, but we want to find better ways of performing it. And finally, we understand the problem, we know there are good solutions, Exploitation, sort of a traditional term of exploitation, applies here. How can we apply good ideas, best practices? This is where professional consulting comes in, where we have a good set of tools and we want to apply it to known problems. And a lot of examples. I don't have time today to walk through a lot of examples with you in each of those spaces. Just a couple pictures here to sort of give you the feel for the type of problems. E-commerce up in exploitation, all the way to World Wide Web, the new mouse, when the mouse was invented. But we can identify lots of prior work that fits into each of those four quadrants. Okay, knowing that, how can we then put together a new topology and a new way of thinking about that front end of innovation? Well, here is our, if you will, tentative solution. It's a process that we would suggest that organizations think about. So what we have, as you can see here, we have the environment, our environmental factors that are supportive of innovation. We have our customers, we have our stakeholders, we have our knowledge base of existing knowledge sitting here that we want to extend with our innovation. And then we have the engine, we have the team. We have the team built specifically with the correct set of characteristics, skills, experience. We want to put them in a supportive organizational environment. So we want to, get them to it. Let them do some work. But here's the new idea, and that is based upon our starting point, our front end of innovation. We have a lens that we send through what we call the Kim prism to say, what are the goals? What are the strategies for these four different types of innovation? Are you focused maybe just on one or two of these, maybe just advancement, maybe just exploitation? Or what is your portfolio? What is your goal of saying, this is the amount of effort and resources we want to put into invention, or into exaptation, or into advancement, or into exploitation? Okay. This type of thinking will now allow us to, as researchers, come up with, if you will, research propositions to say, what do we need to do, what sort of skills, what sort of team makeup, what sort of supportive environment do we want to put together to be most effective in, say, advancement or exaptation or invention. It's not one fits all. Okay, this is the point we're trying to make here. So let me explore that a little bit with you. So the Kim prism identifies and distinguishes these four types of innovation. And we would argue, and our research proposition is that different practice patterns will be best, and it will be dependent upon the type of innovation you want to support in your organization. Okay? So let's think about that. Let me take a little digression. Shirley had a team of students go out in 9 business organizations in Australia and said, does our ideas make sense here? I mean, do we see these 4 different types of innovation in some business organizations? So she went out and typically these students did some interviews with innovation managers at 9 IT organizations in Australia. They identified a set of 11 innovation practices, innovation techniques. I'm not going to go through them all. I'm sure some you've heard of, some maybe you haven't heard of. But these were sort of popular techniques. And the first step was to say, do these techniques sort of adapt themselves effectively to one of the 4 categories? So the team did a little mapping. And, I'm not going to say this is, the rigorous mapping process, because what you see is some of these techniques fall into more than one of the quadrants. Some of them don't fall into any of the quadrants. But a couple of observations here. One is they found very few techniques are specific to invention. You know, getting started on invention is very, very hard. What sort of innovation process would you use to support invention? Okay, they only found a couple that sort of applied. But you can see a lot of them fit into advancement, which is sort of the typical R&D world. A number of them thought about exaptation, and of course exploitation is more traditional, you know, market-based research. And then this is also what they found. And again, this is just, again, research in progress, but they asked each of the organizations, do you use these techniques in your innovation teams? And what you see used mostly are very traditional. Here, market research. They all sort of use market research to understand what where the market is. Brainstorming, design thinking, traditional R&D. And then down to the sort of new ways of thinking, crowdsourcing, open innovation, skunk works, etc. So just a quick sort of empirical little project to think about, you know, do organizations think about innovation in these four ways? They really didn't beforehand, but once they did that little project, then people said, yeah, that's an interesting, good way to think about it. Okay, here's where we are. We are building design theory around these four quadrants. So we feel that this model gives us a basis for development of further research, what we call nascent design theory, that we can generalize across many organizations and activities, government, education activities on being innovative. So just very quickly, as we look at each of these quadrants, we can come up with what we call research propositions. And you can probably think about, well, what characteristics of my organization would I want to have to support invention, where I'm looking at new problems, I don't really have a good solution right now, I really want to be creative and invent something new here to solve this problem. So you want supportive environments that foster creativity, that give people sort of room to explore new ideas. You want supportive colleagues who can deal with some eccentricities as needed to be really creative. And you want to find people who have those type of creative traits. And you want to give them activities like this. Exaptation, which of course requires that there be some interdisciplinary knowledge so that you can draw ideas from other fields. For example, you know, biology, hive behavior, the types of biological behaviors we have seen to be very effective in some IT development of systems. So you want characteristics, again, with highly creative people, but now building teams that are interdisciplinary and diverse are very important here for exaptation. So again, we can come up with some research propositions to measure how effective we are in being exaptive. Same way with advancement, but now we're getting into a little more areas that we're more familiar with. How do we build good, if you will, traditional R&D teams where we understand the problem, but we want to do something new to solve that problem? So we want an open, innovative culture. We want collaborative, disciplined, and creative teams. You know, maybe we're not dealing so much with eccentricities here or interdisciplinary nature, because we want people who are immersed, have a depth in the problem that we're looking at, and can know when we are making some advances. Exploitation, again, a little more traditional. This is where sort of marketing and strategy comes into play here. What new markets do we want to explore? What new markets do we want to exploit here? So again, we want to have very creative people, but now people with a little different sort of profile. People who, you know, want to be able to take what we've got and do better with it. And here we get, again, the professional consulting, the best practice work. So how do we support that activity most effectively? Okay, let me wrap up with just a quick idea of some discussion. Okay, we think that this new model, front end of innovation, KIM model, gives us a new approach. We're starting to understand the categories and topology of what innovation is all about. And we've identified 4. There may be more. I mean, maybe there's another dimension that we could add to this model. So we're still thinking about this. But creative insight for invention, application discovery for exaptation, problem solving for advancement, and appropriation for exploitation. So we think there's some value. Our future research is going to be doing more field studies. We are thinking about some case studies in Germany, in Australia, and in the US. We really think there's some implications here for government support of new ideas. You know, how does the government fund? I mean, in the past, they've gone, well, how do we fund basic? How do we fund applied? There's the Stokes model that you may be familiar with of government funding. We think there's some real implications based on these new ideas. And organizations need to be what we term multidextrous. There have been some work on ambidextrous, appeared in Harvard Business Review. We think multidextrous is the way to go. Let me explore as a final thought here this idea of evolution, because I think innovation and evolution go hand in hand. Human society evolves, technology evolves, and innovation is part of that. Science and technology are a creative tension in my mind, where technology is our human-designed artifacts. It's the prescriptive knowledge base. Science is the theories of nature and human behavior. So it's our descriptive knowledge base. They have a complex relationship, if you think about it. I mean, the back and forth between technology and science. They both evolve, but at very different rates. So where does innovation fit? Where does design fit? Where does learning fit? Let me make just a couple points. In our Shirley and I more recent paper in 2013 in MISQ, we talked about the growth of knowledge and the growth of both descriptive knowledge and prescriptive knowledge over numerous design cycles. So if you look at technology, you look at science, you know that as we move forward longitudinally, that we're going to have growth in both of them. However, technology moves very, very rapidly, as you know. You know, the laws that we have of how technology grows really goes much faster than science can keep up. So our understanding is, in some sense, limited by the fast pace of technology. So observations, technology grows very rapidly. It's a process driven by human and economic utility. Okay, we want to make money. We want to invent new things. Okay, the Facebooks, the Googles of the world, they're not slowing down. Okay, but how do we as scientists, researchers, try to keep up with this really fast pace of technology? Because science is a much slower pace by necessity, because we need to we need to make hypotheses, we need to gather data, we need to test. So technical evolutions precede and drive science evolution ground and direct technology evolution. And it's something to really think about. And we have some real important questions here. Who performs technology and science? Who funds technology and science? Who benefits from technology and science? And just final slide, implications for learning, because as we educate our students on a particular discipline where there's a base of science, there's a base of existing technology, we need to instruct them on the science, which provides their foundations, but we also need to instruct them on technology, which is really rapidly moving. So here's the challenge. How do we keep people and students apace with the rapid growth of technology while still giving them the foundations of science. So instruction in a topic must effectively balance these two, if you will, almost competing demands, okay? And the other thing we need to teach our students in a learning environment is how to be innovative. And this is hopefully some ideas today will let you think about how to not only give them a science base, train them on the latest technologies, but teach them, give them some capability to be innovators themselves. Great. Thank you.
Thanks very much to Alan for his inspiring talk. What happened? No, it's only me. We have a time for one quick question. Yael.
Well, let me just make a quick comment. Evolution is...
You want to hold it?
Sure. Evolution is what is really happening in the world. Now, you'll notice that actually if I flip back a slide, here's some references to some work, and I'll leave that up just so you can see it. But you'll see Kahn's work where he talks about scientific revolution, where science moves in sort of a very different sort of pace because it's sort of discrete jumps of new knowledge, whereas technology, I think, evolves, and I think our learning environments should evolve, not necessarily jump from one idea to the next. So evolution is the way to go.